So hello everyone, welcome to another particular lecture of the radical chemistry course, and this is the class 6. And in this particular class we are talking about the tin hydride mediated radical reaction. So in terms of radical reaction, the tin hydride mediated radical reaction has been a most important type of reactions, and this particular reaction is specifically attracted by the exams like in the CSIR NET or GATE exam. There is a mostly radical based question comes from this particular segment. So let us understand that what actually the tin hydride mediated reactions. So the particular tin hydride mediated reaction is nothing but like if you have any kind of Rx bond where the X should be the iodine, bromine, chlorine, SPH, ACPH, TEPH, isonitriles. So what happened that in presence of tributyl stannous hydride or tributyl tin hydride in presence of AIBN as an initiator. So what happened that this particular bond getting cleaved and generate the R radical, and that particular R radical will nothing but take this particular hydrogen to form this type of alkane or alkenes depending upon the substrate or the starting material, and the tributyl tin X compound has been generated. So this is a very famous reaction in case of radical chemistry. So let us understand the mechanism of the particular reaction. So in every kind of radical based reaction, as I discussed in the earlier lecture, and so if you have missed the earlier lecture, then I highly suggest to check out the earlier lecture and then come here. So in any kind of radical reaction, like what happened that the initial reaction will be the radical generation. So here the AIBN is here. So AIBN will in the presence of temperature, AIBN bond has been cleaved to generate this particular radical, and this radical will initiate the chain reaction here. So what happened that the next will be the propagation. So this particular compound, the tributyl tin hydride, will react with this particular radical to generate our radical, uh, tributyl tin radical, and this particular radical will start the chain reaction, and this will be the important radical which attack with this particular uh, alkane or alkene substance. Okay, so what happened that this particular radical will react and the bond getting cleaved, and in tributyl SNX has been generated, and the R radical is there, and this R radical will again attack with the fresh tributyl tin hydride and takes the hydride from here to generate the RH. This is our product, and this radical will again generate it, and this radical is nothing but again enter this particular step to generate to sustain the chain reaction. Okay, so there will be certain example about the tin hydride mediated reaction, and this is the much more versatile reaction. Like you can see here in this particular compound, you can see that this is the CBr bond is there, and in presence of tributyl tin hydride, in presence of AIBN as an initiator and 60-degree temperature, you can selectively cleave this particular bond to add this particular hydrogen, and the other groups present there, they remain same. Similarly, you can see this particular example where you get two type of CCl bond. One is the this is the 2-degree carbon contains the chlorine, and here is the primary carbon getting chlorine. So what happened that in presence of tributyl tin hydride, so what happened that these two chlorines are actually replaced by the hydrogen, and this shows the versatility of the particular reaction. Similarly, here you can see that here is a CSPH bond is there, and the similar fate has been observed where the SPH bond has been replaced by hydrogen, because in the previous here you can see that X will be the SPH also. and so this particular SPH has been replaced by the hydride. Now there is another interesting reaction has been there by using tin hydride based reaction, where you can actually make a carbon-carbon bond formation by this particular strategy. This is nothing but a Giese reaction. So what happened that if you have a alkene, especially in the bromo or iodoalkene, in presence of electron deficient alkene and our tributyl stannosidrate and AIBN THF. So what happened that this particular addition reaction has been takes place where the new carbon-carbon bond formation has been observed. So let us understand the mechanism of the particular reaction. Like the initial step will be the obviously the radical initiation. Like in presence of AIBN, this radical has been generated, and this radical will attack here to generate R radical. Now, till here it will be similar as the previous reaction, but now this particular reaction, this particular R radical having two different possibility or two different comparative reactions. Like first, what happened that this R radical will attack with this particular tributyl tin hydride compound to getting a termination step and to form a RH, or since in the reaction medium there's an electron deficient alkene was there, so what happened that this R radical will attack in this particular uh, electron deficient alkene to generate this radical, and now this particular radical contains a electron withdrawing group, so that means this particular radical will stable, and now this radical will go in the termination step where it react with this particular tin hydride compound to generate to nothing but basically terminate the particular reaction. So there will be two comparative pathway was there. Now if we have to channelize this particular pathway, then what happened that this alkene concentration in the reaction medium must be much higher over this particular tin hydrate compound, so that this particular reaction will got felicitated. Otherwise, this particular R radical will directly attack with the tin hydrate compound and getting quenched. Okay, so that's why to sustain this particular reaction, the first one is the olefin concentration, that is this olefin. This olefin concentration should be the 10 times then try this particular tin hydrate compound. And also for sustain this particular reaction, the starting material, the starting alkene or alkyne should having only bromo and iodoalkene. Alkane or alkenes will show this type of reaction. Otherwise, this reaction won't sustain. Okay. So organic synthesis pathway, like people are actually looking for a sustainable synthesis or the greener protocol. Now here in this particular reaction, what happened that tin hydride has been used, and all the metals has been used in the particular reactions are fairly toxic enough. So that's why there should be an alternative to do this type of reaction without using the tin hydride pathway. So scientists has discovered the alternate reaction, like instead of tributyl tin hydride, tris trimethyl silane was used to do the same reaction. And to justification of this particular reaction, the scientists given there are two different arguments. That first argument is the like this two, the first part of the particular chain reaction is the SN radical formation. So to form the SN radical, this particular bond dissociation energy should be much lower. So here in the case of tin hydrate, the SNH bond dissociation energy is 78 kilocalorie per mole, and this particular tris trimethyl silane case, the SiH bond dissociation energy is 84 kilocalorie per mole. So there will be a comparable bond dissociation energy between these two particular compounds. And also they have discovered that by doing this type of reactions, this for the both cases there will be the comparable kinetics. Like for by using this type of compound, there has been found that 1.5x time of difference between these two particular kinetics. And for this particular argument, basically currently people are using this compound, this trimethylsilane, to do this type of reaction. And also by using this particular compound, it is the eco-friendly and comparatively greener process, because here no metal has been used. So with this, we have to end this particular class, and in this particular next class, we are talking about the radical-based name reactions, and this will be the last lecture of the radical chemistry. So thank you for listening.